Okay, to start us off, what is a hotspot? So I want you to think about cooking for a little bit. You've got a stove and you've got 4 burners on it. One of the burners is on, but you have 4 pots on the stove. Which is the one that gets hot? Well, it's the one that's directly over the burner. Now, if you move the one that's on the hot burner over to the side, and you move another pot over it, that other pot will get warm. You notice that the burner doesn't change position, but the pots can. That's the same idea how the plates can change position, but the hot spot doesn't move. So if you notice here, you see the hot spot, hot magma is being pushed upwards, and because of convection currents that lead up and to the side and back down, right? Up to the side and back down. Those currents are pushing plates apart, and this plate is actually sliding to the northwest, it looks like in this case. But the only active one, the only one that is actually growing in size is that first volcano. All the other guys are extinct. Ms. G? Now, if you take a look at this one, this is the Hawaiian Islands. You can notice that the one in the bottom right is the only one that has lava on it. This is the only one that's currently active. So back to our stove analogy, this is the only one with an active burner. The rest of these are extinct. But if you look out, from like a wider view, you look back from space down, you can notice that, yeah, Hawaii is right here. But you have all these extinct islands that have gotten worn down and sunk below the surface of the ocean. In fact, some of the ones, like these guys right here, create things known as atolls. So atolls are essentially just the outer perimeter of where the island was, usually built up of coral reefs, and then a very shallow, sandy middle area that used to be the island itself. These were actually very helpful during World War II. We built a lot of airstrips on them. So you can actually see there's an airport right there. It just helps aircraft get from one side of the Pacific to the other. And then we also have these guys. These are known as Guyuts, or flat-top mountains. And again, these are completely submerged. And if you take a look at the timeline, you can see Hawaii down here, 0.4 million years old. That means Hawaii is only about 400 years old. Whereas if you take a look at the Suiko Seamount, it's about 65 million years old. Meaning that the last time this guy saw sunlight was probably when the dinosaurs were walking around. There they are. Now, even here in the United States, we have volcanoes. And much of the time you don't think that, but this is Yellowstone National Park. You see those light blues, greens, yellows, and browns. All these things that you're looking at, this is actually algae. Algae that eats chemicals, chemosynthetic algae. Now, these guys, they thrive in really, really hot temperatures. You can see all the steam coming off. So what's causing all that steam? Well, turns out that Yellowstone National Park is on top of a supervolcano. Yeah, pretty crazy, right? So if you take a look at, towards the bottom here, you could see Upper Mantle, Yellowstone Hotspot. All this area is just a big reservoir of magma. Magma that pushes upwards periodically. It turns out around every 600,000 years, it kind of all just bursts free. So some volcanoes let their lava off slowly every day, just a little bit, and some, like the Yellowstone supervolcano, do it periodically every 600,000 years or so. And actually, just go back to this image. This shows the United States, again, if I can find the picture. This shows the United States about 600,000 years ago, what kind of damage when it erupted it left behind. So you can see all this area was covered in ash. Okay, and that's it for the notes. And you can see here how, again, some go extinct as they move off the hotspot, and new ones are generated. So the direction of the plate changed, and all the islands seem to be moving in another direction now. Okay, so those extinct ones will then break down, eventually wear away, and go below the surface. So all this looks like piles of dirt, but essentially what it is, it's just lava that has cooled off. I'm going to zoom forward a bit. You can see some of the destruction that it causes to structures. Pretty crazy, right? And if we move forward a little bit more, you can even see structures like homes definitely get impacted. It might be moving very slow, but you're not going to stop it. There's very little you can do. Okay, so it says here, use page 5 of the ESRT to answer the following questions. Draw the symbol for each of the boundary activity types listed below. Make sure to label when necessary. So here we have a convergent boundary, and we label the overriding and the subducting plates, and we draw the structure, what it looked like. Now, I'm going to pull up an earth science reference table. So here's a reference table. I'm going to pull up page 5. Right here. I'm going to rotate it so I can see it easier. And I'm going to zoom in a bit. Alright, so if you take a look here at the bottom, you can notice we've got our key, we have our mantle hotspot, we have complex or uncertain boundaries, we have our convergent plate boundary, we have divergent, transform, and then lastly we have arrows, which represent relative plate motions. So the first one was convergent plate boundary. So in order to do that, we'll go back to this tab, and you can see where it says convergent. I typed the word overriding, subducting, I drew a line, and I dropped some boxes on there. So let me show you how I did that, just so you can do it as well. So we go to Insert, Shape, or actually in this case Line. I'm going to draw a nice straight line from one side to the other. Then we're going to Insert, Boxes. We need like boxy shapes because if you remember, it showed it as boxes, so we'll draw a box. And I'd like to color in that box. I'm going to go to Fill Color, and I'm going to fill it in black. Okay. Now, so we don't have to recreate this, I'm going to hit Control-C and then Control-V. I'm going to copy and paste it. The other way you can do it is go to Edit, Copy, Edit, Paste. And then I'm just moving around my arrow keys. So there I have my convergent boundary. I just chose to do 3 boxes. You do as many as you want. Now I need to also list which side was overriding and which is subducting. I'm going to go back to this page. You can see the overriding plate has the boxes. The subducting plate is smooth. Back to this page. Insert, text box, overriding, insert, text box, subducting. Okay, it's as simple as that. I'll do one more with you just to make it a little easier. Here we've got mantle hotspot. If we go to this page and we take a look, our mantle hotspot's down here. It looks like a little explosion. And usually you could find whatever shape you need just by going to Insert, we'll go to Shapes, And I'll just look around until I find an exploded starburst shape. And I think that right there looks like a good one. And there is my mental hotspot. So you'll do that for each of the other ones. So you can just draw them using the tools that you have available. What type of plate boundary exists between the following? So the first one says North American plate and the Eurasian plate. Go back to your reference table, page 5. Find the North American plate. Find the Eurasian plate. And then look for the boundary between the two. It's the boundary with the double lines that are spreading apart. And if you recall, that's divergent boundary. So we can go back to here, and we can type the word divergent. You'll do the same thing for the rest of these. Today, the only thing you have to do, and you got 20 minutes to do it, is complete this table and to fill in this part of the chart. Tomorrow, you'll also have to do these. And in case you're one of those people that likes to get, ahead of the game, I don't blame you. I want to show you how to do these as well. Pretty simple. For this one, for number 3, it says, determine which plate is the overriding plate and which is subducting. So I did the first one for you, the Eurasian plate and Indian Australia. Go back to our chart. There's the Eurasian plate. There's the Indian Australian plate. You'll notice separating them is this boundary. It's blocks on a line. And if we go back, remember blocks on a line are convergent boundaries. Who's got the blocks? It's the Eurasian side. So in this case, the Eurasian side, let's go back to this page, the Eurasian side would be overriding, and the Indian Australian would be subducting. Right. And then just a couple other little things just to practice. Determine the latitude and longitude. Be sure to include units. So let's go to this page. Tasman hotspot was first. You can see Tasman hotspot's right there. It looks like it's right on 160 east. Right? We know it's east because if that's the prime meridian, everything to the left of the prime meridian is west, up to 180. So I know this has to be 160 east. And how high up is it? Well, if we find it and we move sideways, it looks like it's about 40 degrees south. So if you remember, we always do latitude first. So that would be 40 south, or actually south 40, comma, east, what was that, 160? There we go. Okay. Then you have one last question at the end. Why does Japan experience a large amount of tectonic activity? Right. So, I mean, based on everything we've learned, that's a very simple question. So just answer it there. All right. If you guys have any questions for me,